x, I should expect to get two values for x, right? So let's do it. If I plug in the -4 to, again, the bottom equation, x squared minus 4 equals 5. So talk me through the steps of solving that equation.
Subtract 5 over.
Whoa, I wasn't expecting that. What'd you say, John? You said add the 4 over, right? You said subtract the 5 over? I like both of them. I would have added the 4 over. Hold that thought. Let's do that. See, I was looking at x squared equals 9, and how do I solve this equation? Plus or minus the square root. If I'm using a square root, remember, to get rid of squaring, I have to do plus or minus. Not vice versa, but... So this means x equals plus or minus the square root of 9, which means x equals positive 3 or negative 3. So 3, -4 was one of those points, and -3, -4 was the other point. Those are my three solutions, right? But I kind of, now that I'm thinking about it, I like what Samantha says. What if you subtract the 5 over instead? That's a difference of squares. And you can factor that. You can solve that by factoring, right? That's x plus 3 times x minus 3, from which you get -3 or positive 3, right? And if you did that, and you factor it correctly, you don't run the risk of forgetting about the plus or minus, which I know you're not going to do. You're going to remember plus or minus regardless. Nobody ever forgets the plus or minus. I like that. So there you go. That's a way to play systems of nonlinear equations. Now we've got time.